Charles's law says that volume divided by temperature is equal to a constant, and the constant being the constant of a particular closed system, where pressure and the number of molecules is going to be held constant. For me, I always thought of all these laws and just in terms of pressure and just didn't even bother with these things. Pressure is equal to force over area. So in this particular system, pressure is being held constant. In Charles's law, number of molecules and pressure is constant. If I were to adjust the volume or the area in order to maintain the same pressure, I'm going to have to adjust the force. And the force in a gas is the force of the molecules striking the surface. It's the kinetic energy of the molecules. So that can be adjusted by raising or lowering the temperature. So for instance, if I were to raise the area of the volume, if I had a cylinder, say it's halfway down, and then I move it back up, and the pressure is constant. If I move this up, in order for this to maintain its position here, the pressure from the outside needs to still be equal to the pressure from the inside. And since I've increased the area, the pressure is going to be held constant in the mole. So normally when I increase the volume, it just decreases the pressure. Or if I decrease the volume, it increases the pressure. But if the pressure is to remain the same, then something else has to change. In this case, the force. In order for this increase in volume to be maintained, these same number of particles are going to have to work harder. They're going to have more kinetic energy to maintain this. So that is why temperature is a factor in this particular law. So in order for this increase in area to be maintained, now it's being divided by a larger number, I have to increase the force. So I have to increase the temperature. And that's what this law is basically saying. So for instance, if I want to double the volume, what's going to have to happen to the temperature to still be equal to this constant? Well, I look over here, 2V, and I can just say, well, I'm going to have to multiply the temperature by 2 in order to be equal to B still. So this is how this particular law works. The idea is I have a gas and I want to maintain a particular pressure. In Boyle's law, when I adjust the volume, then the pressure just adjusted. But if I want to maintain that pressure, the molecules are going to have to work harder in order to deal with an increase in pressure. And by the converse, if I was to decrease the volume, these molecules would need to slow down and not strike with as much force. Otherwise, it will push the lid back up. So in order to decrease the volume and maintain the same pressure, I would have to lower the temperature. So let me do a quick example. Suppose I have a gas at 15 degrees Celsius, 1 atmosphere, and it's 2.58 liters. And I want to adjust it so that it's still at 1 atmosphere. So the pressure is still constant. Still the same pressure. I want still the same pressure, but the temperature to be raised to 38 degrees Celsius. And my question is, what will be the volume if the pressure is maintained and the temperature is raised from 15 degrees Celsius to 38 degrees Celsius? Now, it's important to know that when dealing with almost anything in chemistry, it's important to convert Celsius to Kelvin, because Kelvin is an absolute scale. Celsius only is basically a scale of the freezing and boiling of water. But in chemistry, I'm not really interested in that much, so I need to convert this to Kelvin, and I do that by taking the Celsius and adding 273. So I take 15, add 273, let me get my calculator out. I haven't worked this out yet. Not that I need a calculator for this, but I'm going to need it soon. This is 288 degrees Kelvin. And over here, I might as well just convert this one right away as well. This is going to be 311 degrees Kelvin. But what I'm going to need to do is use my law. V over T is equal to B. So I can change that law to be V1 over T1 is equal to V2 over T2. And this is in fact how many books write out the law. I'll circle this. It's not the answer, but this is what I'm going to use. So this pressure is not really important. What's important to know is that the pressure is held constant. So I'm going to use Charles's law. So I have volume 1, which is 2.58 liters, being divided by 288 degrees Kelvin. And this is equal to my unknown volume 2 over 311 degrees Kelvin. Now, I can just multiply this over to the other side, divide this, and then I'll be left with V2. So 2.58 divided by 288 is equal to 0.008958 liter kelvins. Multiply. Let me just write this out. Multiply both sides by 311. Okay. So this is going to cancel, kelvins will cancel, and I'll be left with just liters. This is equal to 2.79 liters.